Good morning, ladies and gentlemen. I want to thank the OFC community for giving the opportunity to be here and share some of our opinions about the optical network in China and how China views the challenges and opportunities in the coming 5G and cloud era. Today, I will talk about the three topics. The first one is MC-OTN. We introduced for 5G and cloud network. The second is FTTX development in China Telecom, the Optical Network 1.0 strategy. And the last one, I will talk about the ROADM network, just finished a few months ago, the Optical Network 2.0. But first, I hope to make some brief introduction about the China market and China Telecom. The economy of China has booming for quite a long time. From chart, we can see a large portion of now we are the second largest economy in the world. A very large portion of the GDP is driven by RCT industry. Even though only 7% of the GDP are directed from the RCT, but the other 24% are driven by the digital economy, like the online shopping, online finance, social media, and gaming. Digital economy is the most innovative of the part of the China economy, which is deeply dependent on the RCT industry. So altogether, RCT have contributed 1/3 of the China GDP, and this portion is likely to be more high in the future. One reason for RCT industry became so more important is that China has a very high internet penetration level. By the end of last year, China's internet user is about 772 million, and this number is likely to be more higher, especially that the most popular web-based applications like as the electronic payment, online shopping, and dockless shared bicycle. You can see a lot of our dockless shared bicycle in the street of San Diego. Yesterday, I used my cell phone to scan the QR code to open the one bicycle and ride a few miles. This is a very good experience. Together with the high-ability train, this is called the New for Great Innovation. This is a huge market full of opportunity for Chinese ICT companies. We have the fives, BAT, Alibaba, Tencent, and Baidu. And on the communication provider side, we both the China Telecom and China Mobile are listed in the top 10, world top 10. As a result, the traffic have grown very fast. In the last decade, the backbone traffic increased 47% in the last decade. We expected to see in the next decade, we maintain 40%, a little slightly low than previous decade, but it's still very high. According to our planning department forecast, the traffic of the 2025 will be 11 times of the 2018. This rapid traffic is also a big challenge for the carrier. We see the traffic increase 40% every year, but the revenue is only 10 or 5%. This is the big gap between the traffic and the revenue. So in 2016, we officially started the CityNet 2025 project. This is a very big network re-architecture project. It's similar to the AT&T Domain 2.0. The project is to boost the innovation, simplify network operation, and break down the OPEX and the CAPEX. The CityNet 2025 is a very big project and cover multiple level network, but optical network is always the most important part. So basically it contains 3 subjects. Is MC-OTN, ION 1.0, and ION 2.0 is also my main topic today. First, let's talk about the 5G and the cloud-oriented optical network. But here's some basic figure about China's Telecom's mobile service. By the end of the last year, we have more than 250 million mobile subscribers, and most of them are 4G users. China Telecom today is already the largest LTE FDD operator. We have 1.16 million base stations, provide better coverage than most developed countries, maybe including this country. As you can see from the chart on the right side, the daily traffic have been growing at a tremendous growth. In 2016, the average data flow of usage of per user is less than 1 gig, but last year is about 4 gigabytes. So the 400% increase is a tremendous growth. The one reason for this huge growth is the internet application get more popular. The second reason is the unlimited data service package promoted by the China Telecom. China also will be one of the first in the world to have 5G commercial deployment. You know, China government is very, very, very active in the 5G network. China Telecom will finish the 5G field trial and test and field trial in 6 cities this year. Maybe more cities will be added to the list according to the government's plan. This massive investment of 5G will take place from 2020 to 2025 and last probably 1 decade. The investment of 5G-related industry may last for a long period of time and at a much larger scale. Here are the 3 important requirements for the 5G barrier network. First is high bandwidth. The download of the 5G will reach 3 to 5 gigabit, compared with the LTE is only more than 100 megabit. The increase, the bit rate is 20 times. So as a result, we need n times the 10 gig of the bandwidth in backhaul for each CO. Second is ultra low latency. There are a lot of the scenarios, such as VR, AR, and auto-driving, and the industry automation. They need end-to-end latency less than 0.1 microsecond. The third is the high time precision, 1 microsecond for basic service, and 100 nanosecond level for service coordinated over multiple base stations. In order to meet all requirements, network strategy needed to change it. First, 5G will work at 3.5 gigahertz spectrum. Today, the 4G will work at the 1.8 gig spectrum. So it means if you want to get the same coverage as the 4G LTE, you might need twice of the base station density. So what I just say today, China Telecom has more than 1 million base stations, but for 5G, we may need 2 million base stations. This is a huge number. The second, China Telecom prefers C-RAN architecture for wireless network because it helps to save on-site room occupation and cost, simplify the network maintenance. For 4G network, nearly 50% we use the C-RAN structure, but for the 5G, more and more, maybe 70 to 80% will use the C-RAN architecture to save the maintenance cost. And the last architecture change is the cloudification. For the 5G, the cloud network is also cloudified. And the MEC, the mobile edge computing nodes, moved down to the edge of mature, which require more meshed and flexible connections. This is the 5G barrier architecture evolution. So in the Fronthaut, both the fiber, direct fiber connection and the WDM will be deployed. Fiber is easy and cheap, but the WDM can be very useful when the fiber becomes limited in some area. We prefer fiber because fiber is, if you have enough fiber is the most easy and cheap. But in some area with not enough fiber, you must use the WDM as a supplement. There are 3 key technologies. The first is 25 gig eCPRI. This standard just released last August. Second, we prefer the 25 BiDi technology for saving fibers and better synchronization. We are very, we see the 25 gig BiDi mean you use one fiber to carry both bidirectional signal. So you use one fiber to connect. You connect to the base station. In case of the fiber short, WDM will be a very efficient solution. In fact, we just finished some eCPRI of WDM or fiber in our lab. Results show that the solution can provide latency about 1 microsecond and jitter at 1 nanosecond. According to our estimation, around 2.5 million base stations and 3 cells per station, there will be 15 million of 20 gig optical modules. This is a very big market for 25 gig. We believe the 25 gig interface will become more and more popular. The previous is 10 gig, the next is the 25 gig. So this is for the mid-haul and the backhaul. As to the mid-haul and the backhaul, we believe the OTN-based solution is the best fit. OTN has widely deployed in our metro networks, and is a perfect candidate to satisfy the 5G requirement on bandwidth, latency, and flexibility. However, today OTN technology needs to optimize for the 5G. For example, low latency for simplifying the mapping and the ORM process from more than 10 microseconds to less than 1 microsecond. We have just proposed this optimization known as MC-OTN in ITU-T study group 15 this January. Lastly, but maybe the most importantly, to satisfy the flexible connection among multiple CUs and MECs, some layer 3 function may introduced in OTN equipment for dynamic 5G service. So far, we have already drafted the key spec with main Chinese vendors and plan to carry out a lab test and field trial this year later. This is the concept of the MQ3C OTN. The first M stands for the mobile optimized. OTN needed to simplify and become more flexible with the layer 3 function. The second M stands for the multi-service, and we will have the multi-service from both individuals and enterprise users, covering both mobile and fixed network application. And the third M stands for metro. MQ3 focuses on the metro application. C stands for the cloud. In cloud area, MC-OTN will also support future all cloud network, and we will require high bandwidth network slicing with intelligent control. Technology like the 200 gig, 400 gig, FlexO. FlexO is for the network slicing, and the SDN maybe all needed. As I said, optical network will play a very important role in 5G and the cloud era. A new industry forum was established last December in China. The NOOF stands for Next Generation Optical Forum. The mission of the NOOF is driving the collaboration in the industry to speed up the innovation, in optical solutions. Currently, there are 20 members enterprise, 20 member companies from the whole industry chain, including carriers like Telecom, Chengliang, and the vendors such as Huawei, ZTE, and the chip supply, chip and optical module supply as Maxemi and Finisa. We have recently published the 5G white paper. You can scan the QR code, visit our website, and download the white paper. Now let's move to the next topic, all optical network, LON 1.0. LON 1.0 as China's FTTH strategy targeted to reach over 90% of the fiber access household penetration and up to 100 megabits access bandwidth. We started the project in 2000. From 2000 to 2007, we realized fiber to the curb. From 2007 to 2011, fiber to the building. And finally, the project is finished in last year, 2015, with fiber to the home, from FTTC to FTTB to FTTH. Now, with more than 90% of the access, with more than 90% of the fiber penetration, our users can enjoy the access rate of 100 megabits with fibers. This speed has surpassed Korea and Japan. Maybe we're the number one, the access speed rate in the world. This process lasts more than 17 years from the FTTC to FTTH. One driving force for high bandwidth is video. As you can see from the chart, today, China's Telecom's IPTV users are steadily increased over years. IPTV means you use broadband to transmit the television channels. Today, there are 100 million families use China's broadband, fiber broadband to watch TV. We are maybe the second largest television channel operator. And with fiber to the home, 4K video can also provide. This is one of the most advantages for Telecom to compete with other television providers, because we can provide 4K video in our network. The 4K video consumes most of the bandwidth, and we expect the 4K share to even high in the next 3 years, reaching over 15%. Another driving force is coming from the smart homes. Here shows the number of the users for the top 3 smart home applications. China Telecom is want to build the smart home ecosystem You know, we have the gateway in the superstar's home. We can turn this gateway into the gateway of the IoT, Internet of Things, to collect the information, to provide the video call, to provide the family cloud, and to provide the home security surveillance. So this is the top 3 application for smart home. We, by estimation, there were around 140 million users in 2020. This slide shows the roadmap of the next step. ION 1.0 plus. You know, we have finished the 1.0. Next is the 1.0 plus, which will provide better coverage, high bandwidth, and more intelligence. In 2020, we will provide the 1 gig access for some developed urban area with child of the with child 90.2, 50 GPON or WDM PON. We provide 1 gig bit access in some developed area. But in 2025, smart home user will reach 200 million, and 1 gig access will be available in the entire network. Let's move to the last topic, ION 2.0. Today, internet application, cloud application, and a new application from OTTs require more and more data center. Data center is another very hot point for competition. The network is now evolving from previous PSTN centered to the data center centered. For data center centered network require large bandwidth, faster provisioning, and low latency. Data center are reshaping optical network. Deploy ROADM is very necessary and is the best solution we have seen. Charlie Telecom backbone network aim to serve more than 100 data centers, but only half of the data centers are ourselves. The other data centers are from Alibaba or other internet content provider. Charlie Telecom initiated the ION 2.0 strategy by deploying the ROADM network for the first time. There are 3 key values. The first is the minute levels, the service provision. The second is faster service restoration within seconds, thanks to the WSUN. We are the first to use the ROADM network with WSUN functions. And the last one is the ultra-low network latency, down to only a few milliseconds.
The ROADM network along the middle and lower reaches of the Yangtze River is the first all-optical intelligent network in China with the largest capacity worldwide. The network adopts the industry's highest 20-degree ROADM networking, ultra-long-haul 100-gig board technology with excellent performance, and the mature commercial WDM ASON plane. The core capabilities of this all-optical network include rapid service provisioning, fast service recovery, and differentiated services assurance. A traditional OTN network requires manual fiber connections, while a ROADM network automatically creates optical channels. Services can be rapidly provisioned across backbone networks. The WDM ASON technology provides millisecond-level service protection and second-level service recovery to ensure that services can find recovery routes as long as system resources are available, guaranteeing high reliability. China Telecom will strive to further promote the evolution of optical networks, accelerate network upgrade and reconstruction, provide better user experience, and lead networks into a new era of all-optical interconnection.
Okay, the commercial time is over. Next, we're planning to expand the ROADM network to other regions. This is the first one. 2 more ROADM networks will built this year later, similar scale. So the biggest benefit brought by ROADM is the improvement in the efficiency. Here are the 2 examples. Before the use the ROADM, we can only configure 1 or 2 100 services per day. This is due to a lot of on-site configuration. We must send an engineer to do on-site configuration. Now with ROADMs, we are able to provision more than 50 100 services per day because most of the configure can be adopted in minutes by control plane remotely. A second efficiency is the network get more resilient to fault and error. ROADMs provide wavelength level restoration. Service can be recovered in minutes instead of days and weeks in the past. This also means we no longer need to fix the failure immediately, which saves a lot of capex. This is the efficiency brought by the ROADM network. But from the carrier point of view, we are not entirely satisfied with the today's ROADM. First, high dimension is needed. Today, ROADM only reach 20-degree maximum, which is not enough, especially for the metro application scenario. There are more directions and more and dual ports and directions. We are expecting the 32, 40-degree ROADM to improve the network agility and to form a fully meshed network. The second direction is CDC. CDC is the colorless, directness, and contentionless. Contentionless can help to avoid wavelength conflict, to avoid the wavelength conflict at drop ports, and is suitable for SDN control environment in the future. Because everyone talk about SDN. SDN will be used in the future in the home network. The software-defined network, the contentionless ROADM is more suitable for to do the software-defined. But we are expecting but another problem is the high cost for CDC. We are expecting a simple design of the CDC, and most importantly, the cost effective. So we are very interested in the CDC ROADM, and we'll follow closely. As the ROADM gets popular, the way of the fiber connection also need to evolve. Traditionally, we use the direct fiber connections, which is very complicated. And in some sites, several hundreds of the connections or more WSS are needed. This is a total nightmare. Now, some vendors provide the fiber shuffle with the MPU connector, which simplifies the connections, reduce only a few of dozens. The next step might be the optical backplane with absolutely zero fiber connection needed. So for ROADM, we need to simplify the fiber connection. We have talked a lot about ROADMs, but this doesn't mean we should give up OTN. ROADM-based optical layer switching and OTN-based ODUK switching will play different role in our network. ROADM will take care of the 100 gig plus wavelength level service grooming in backbone network to provide the low latency and service routing at the optical layer. While OTN will continue to take care of the ODUK level service, providing multi-service access capability and the best flexibility in metro area. We must combine the two network element advantages to provide a better solution for our network. This is a summary of my presentation. In summary, optical network needs in China are now transforming to better satisfy the coming 5G and cloud service. In access network, our optical network 1.0 have been realized. And the next step is to achieve 1 gig access in the entire network. For the backbone network, our optical network 2.0 will be implemented ROADM and WSUN for one-hop connection and fast restoration. And the concept of the MC-OTN is proposed. OTA and WDM will be introduced to mature edge. You can see this changes. WDM and OTA previously only used the backbone mature core, now move to the edge, even to access. Finally, I would like to end my talk with a famous quote from Confucius. Confucius is a very famous philosopher in Chinese history. To accomplish the mission, we must sharpen his tools. The mission here, our mission is 5G and codification. And the most important tool is optical network technology. To make 5G and codification a reality, we must encourage more collaboration and innovation in the community and enhance the platform like OFC and NOOF. We are very optimistic, and we believe a great future ahead of us. Let's all work together towards it. Thank you, and thank you for your time.